So my topic is autonomous vehicles. Um, I know it's probably a popular topic. Hopefully I can offer something unique. But the reason why I was interested in this is because uh, early on in university I took on an interest, and I joined the EcoCar team where I did some work on sensor fusion, which is part of how the car detects other cars, stuff like that. And my chosen transportation problem is congestion. So I accidentally told you my motivation without advancing to the slide, but yeah, so first and foremost, as I mentioned, I'm interested in the technology. Secondly, since this is like a transportation engineering class, it got me thinking. I've been working on the tech and I know a bit about it, but uh, everybody says autonomous cars are gonna completely change transportation. And so I wanted to better understand the science, the studies, and the predictions behind that. So first of all, I think it'd be interesting to kind of talk about where we are right now in terms of autonomy. Um, so here we see the SAE levels of autonomy. It goes from 0 to 5, and this is basically the industry standard. So 0 is no automation, and 5 is full automation, right? At that point, you literally don't need a steering wheel. The car drives itself, and you just sit back and relax. So where are we right now? It kind of depends which car you're looking at, but Tesla, for example, we're at level 2. So if we go back, level 2, partial automation, that means that at no point is this car capable of driving itself without human supervision. And so another example is Waymo, which is a company that was previously owned by Google. Now it's a sister company. And Waymo could be said to be pretty much fully autonomous, level 4 or 5. Um, they have a taxi service called Waymo One that operates in Phoenix, in Arizona, and as you can see, no driver. Passengers are just being taken from uh, start to destination. On the contrary, this is very localized. So this is only in Phoenix. And so if you took this car elsewhere, somewhere else in the States, it would not be nearly as safe. And so, an autonomous car is a complex system. There's a lot of tech behind it. And so or at least I want to focus on the automation part. And that can be said to be like the ML of the car, which is making the driving decisions. And what this may look like one day is something like this. Yeah, this is pretty crazy. No stoplights, intersection, so many lanes, and everything just kind of works. But yeah, I want to point out that something like this is only going to be possible with full automation, right? Like if you put a human in this system, it's not going to be able to keep up. It's going to drastically reduce the efficiency of the system. So this is like full adoption. Okay, so what about like right now? So this is a paper, and they're looking at the problem of mixed autonomy. And that's basically a road setting where there are both human drivers and autonomous drivers. And what they wanted to do was focus on the technology of reinforcement learning. This is an area under machine learning, which is pretty important to self-driving cars alongside deep learning. And they wanted to create a benchmark for assessing reinforcement learning driven autonomous cars in mixed autonomy traffic, so that we can kind of advance in this field. So one of the benchmarks is this closed loop figure eight. And let's just watch this for a second. Yeah, so as you can see, God, let's go back. So what they're doing is they are gradually increasing, or they're gradually replacing human drivers with autonomous drivers. And these autonomous drivers are controlled by reinforcement learning. And they found that just by replacing one driver with an AV, you get, up to double the average speed. And as you increase that number all the way up to 14, the efficiency is just improving. And so I guess the core question of this presentation is, how does this, what was the word? How does this technology address the chosen transportation problem, or in this case, congestion? So, obviously there are two sides of the coin, right? So as humans, we sometimes do stuff like random brake checking, drive in the middle of two lanes, inconsistent speeds, going too slow on the highway, a lot of illogical things, right? And so imagine you're just increasing the number of AVs on the road. You're going to get more homogeneity of driving. Because these cars tend to be more consistent, for example, in their acceleration and deceleration. And secondly, going back to that simulation of this very fluid and very dangerous looking intersection with a bunch of cars, when you start training an AI to drive a car from scratch, it's going to be fundamentally different from humans. So it's going to be able to drive in ways that we can, and what you may call the mathematically optimal way. Okay, now on to the bad. There's also, outside of a simulation where it's so simple, there are going to be geographic and socio-graphical effects. So when we were looking at the utility function in class, the important things were time, cost, and comfort. And so with autonomous cars, let's say fully autonomous, you as a person are no longer going to have to drive yourself. So you can do other things while the car is driving. And if you can do that, then perhaps the length of your commute becomes less important because you're not sitting through rush hour, stressed. And as that happens, we're going to see more urban sprawl. Secondly, there's a study where the researchers looked at the effect of partially automated cars on congestion. Partial automation is the stuff we have right now. So like adaptive cruise control, where you're like following a car at a set time gap. And they found that the time gap tends to be larger with ACC than with humans driving. And what that means is less cars can fit on the road. Congestion. And thirdly, once you kind of get autonomous cars, a lot of people who couldn't drive originally are going to be able to travel in cars, right? So my grandma, she can't drive. She takes the bus right now, but wouldn't she prefer to have an autonomous vehicle, right? And so as you increase the number of cars on the road, yeah, there's going to be more congestion, all other things equal. So this is a graph that seems pretty wrong. It's from a paper all the way back in 2015. And so going on this, right now, we would, in phase 3, you see, it says complete autonomous capability. And we're not there. Okay, so the way forward, right? So I'm going to kind of look at this from a technological point of view because that's the big problem here right now. Like, we're only at level 2. How do we get to level 5? So we saw with Waymo, they have very good autonomy in certain areas where they have been driving their cars as taxis, collecting data, and it's good. But to see the scale of autonomy, which will like drastically improve congestion, we need a generalized self-driving car that can function in all sorts of environments. So right now, I list the areas where Waymo has their fleet, and the way forward is for them to add more cars and operate in more areas, which is their plan. Tesla kind of needs to play the catch-up game in terms of ML and like algorithms. Google got the head start. They were the first to start using not Google. Well, Google, yeah, got the head start with using ML self-driving cars. That's why they're so advanced. Tesla has the advantage in terms of data, right? They're selling their cars commercially all over the world. They have hundreds of thousands of cars that are giving them data in all sorts of localities. And that's going to let them create a generalized car. And of course, other OEMs are important too. And we're seeing companies partner up with AV companies, such as GM and Cruise. And